Let's look at this problem called Pacific Atlantic Water Flow. Looks like a little big one. Let's have a read. Okay, there is a M cross N rectangular island that borders the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. So we see this left and right edges are being touched by Pacific Ocean, and the right and bottom edges is being touched by Atlantic Ocean. And this is the island. Okay, let's read further. The island is partitioned into a grid of square cells. You are given an m cross n integer matrix heights, where heights RC represents the height above sea level of the cell at coordinate. Okay, so these are all different heights. And the island receives a lot of rain, and the rainwater can flow to a neighboring cell directly north, south, east, and west if the neighboring cell's height is less than or equal to the current cell's height. Makes sense. Water can flow from any cell adjacent to an ocean into the ocean, right? So from any of these cells on the boundary, water will flow into the ocean. Now, what about this on the bottom left and the top right? Which ocean will it flow into? Okay, let's see. Written a 2D grid of coordinates result where result I equals to RICR denotes that rainwater can flow from cell to both the Pacific and Atlantic Oceans. Okay, so obviously this guy can flow to both Pacific and Atlantic. This guy can flow to both Pacific and Atlantic. Um, Water can flow from any cell adjacent to an ocean into the ocean. So the only two cells which can really, just looking at this individual cells, like one, all the obviously all of these first four cells in the first row will go to Pacific Ocean, and the first four cells of the first column will go into Pacific Ocean. The last, this five and this five, they can flow into both Pacific and Atlantic, and all others again only Pacific, only Atlantic. Um, Return a 2D list of grid coordinates result where result of I equals to RISCI denotes that rainwater can flow from cell RICI to both Pacific and Atlantic. All right. So is it just that, does that essentially mean any cell that's linked to this, any cell that's linked to this, right? So should I just do like two graph traversals starting from this point, that is one, and starting from this point, that is another. That is all, is it? And the way that would be, hey, it would be you would be linked to this guy if you are your height. So for this guy, there are only four possible, for every node, there are four possible neighbors, and you are linked to your neighbor if, so because I'm starting from here, I would want my neighbor's height to be greater. So it's what can come to me. I'm trying to build that sort of a relationship, and it's a directional graph. And because I'm starting from this, I would want to go up and not down, right? Because this is the last guy that it would reach. And so here, for example, the highlighted ones are the ones that are connected. So for example, we see six water can come to five, seven water can come to six. That is fine. So seven, six is fine. Five, what about five? Why is only uh, can five water flow into four? I don't know why this five is highlighted. I understand this four, and this five, and also why this five. I don't understand it. Let's understand the example. Heights equals to this. The explanation. The following cells can flow to the Pacific and Atlantic Ocean as shown. 0, 4, uh, 0, 4 Pacific Ocean, 0, 4 Atlantic Ocean. So 0, 4 is these two, which is fine. 0, 4, 4, 0 is quite basic to understand. 0, 4 and 4, 0 are quite basic to understand. From 1, 3 to 0, 3 is Pacific. So I understand now. Okay, so it's not just these two cells. It is also that let's look at this guy. This is okay. So for five is I'm not quite clear. Everything else is for five it might be here from five I can go to five to four to two. I can also go from five to three to one, right? And go into the Pacific and go into the Atlantic. Ah, makes sense. So it's not you can it's not necessarily just through this one path is where you get to the Pacific and Atlantic, like just not through these two cells, but it could be you have two different paths for and this is clear from here, like 0, 1, 2, 0, 1, 2, like 2 comma 2 is as an interesting example. So 2 comma 2 it goes to 1 comma 2, 0 comma 2. So 2 comma 2 and then 0 comma 2 and then 1 comma 2, sorry, no, 2 comma 2 to 1 comma 2 to 0 comma 2, yeah. So this is the path that, and also this as well. So this path goes into Pacific Ocean, this path goes into Atlantic Ocean, 2, 3, 2, 4. It's actually considered this one, but like from 5 there are multiple paths, right? 2, 3, this goes into Pacific, this goes into Atlantic, this goes into Atlantic, this goes into Pacific, and so we understand that. So now we have to figure out, um, that just means we have to figure out all Pacific and all Atlantic ones. So all the Pacific ones will include all of these, all the Atlantic ones will include all of these. And from each and every one of these cells, we have to do a DFS traversal. And we can do an adjacency list based. So the sort of the heights array tells you whether or not you can move to the next cell. So could we do something like what are all the nodes to which the Pacific Ocean is connected, and what are all the nodes to which Atlantic Ocean is connected? So how would I find all the nodes to which the Pacific Ocean is connected? Would be I will start doing a DFS or like a traversal from each and every one of these nodes, right? And whatever nodes that I visit, I will add them into a set or something, and I will call them. These are all Pacific Ocean nodes, and then I'll do the same thing for the Atlantic Ocean, and then I'll get the common ones. Okay, makes sense. So let's start doing that then. Okay, so what that means is I am building two maps, right? I'm building one map to say, or rather a set. So I'm building a set of I can build a set, or I can also build like yeah, I guess building a set is easier, but I can also build like Pacific nodes, and I can do like a Boolean array, and I can mark everything as false, and then once it is true, then it will be so I'll do a Boolean array of size called Pacific, and I'm gonna do um, new Boolean, and I can take size same as heights array size. So heights dot length, and okay, now I will similarly build a similar array for Atlantic, right? And now let's build the Pacific array. So what that means would be I will start doing a DFS. So first I will take the first row, and so for that I'm doing I equals to, so I'm gonna take column, right? Or I can take j, so j equals to 0, j is less than height 0 dot length j plus plus. And from each node I will do a traversal. So for each node I will do, if it's not already visited, right? So if specific of ij I is 0, so specific of 0 j is not equals to true, or rather if this has not been marked into as part of Pacific Ocean yet, then I'm gonna do um, just I'll call it DFS. So DFS, I'm gonna pass the heights array. I'm gonna pass the INJ, which is 0 and j, and I'm gonna pass this specific, and and that's it, right? And let's build this DFS first. So you do void DFS. You have your heights array. You have your INJ, and you have a sort of a visited array or marked array that you say, hey, I'm part of my water can go into Pacific Ocean. Or rather, here I will just call it visited rather to make it easier, or generic, right? It's visited. So now, obviously, if it's already visited, if visited of I j is equals to equal, if visited rather, so if visited, you just return right away. Or other things are also there. If I is less than 0, j is less than 0, I is greater than equals to height dot length, j greater than equals to height dot length. What else could be there? My water cannot. So I think you need to know your child, isn't it? Or maybe we check it before calling. Okay, we'll check it before calling then. I would rather prefer call checking it here. Okay, so then you need your parent IJ as well. Unfortunately, when you need your parent IJ or parent's height, right? Um, okay, we can check while calling the DFS. So then essentially what happens is um, I'm parking it for now. I'm saying I will check it before calling integ. So I'm saying I'll have this. I'll ignore the bit. I'm gonna do on moves equals to new in, and you can go in 4 different directions. 0 minus 1, 0 1, 1 0, minus 1 0. Only of the 4 directions you can go to, and I can make this a constant thing. Right, all of that. And so you will do visited of ij equals to true, and then you will do for each direction in moves we can do x equals to I plus direction of 0, y equals to direction of y, sorry, j plus direction of 1. And now I will actually do all of this check, which is if x is within the range, so x is greater than, if x is within the range, y is within the range, so x is less than it's dot length, and not or, now it's all and, right? So x has to be greater than equals to 0, y has to be greater than equals to 0, x has to be less than heights of length, y is less than heights of length. What else? And it's not already visited. So visited, it's not already visited x and y. And so now this also I don't need. There is one more condition. I can go from current to the next guy only if its water is lower. So heights of xy is less than equals to heights of ij. If all of this is true, only then I can do DFS of heights x, y, and visited. Right, and that way I'll keep doing visited and I'll keep marking visited as true. At the end of this, everything who is connected to this guy, or everything from first row that comes to the Pacific Ocean, uh, would come to the Pacific Ocean, would get added. Uh, for that corresponding index in this specific array would become true. Let's also do the first column for the same, right? So for first column, you'll do I equals to 0, I less than heights dot length, I plus plus. You can do, if not, Pacific of I0, and obviously 0, 0 is already covered, so here let's do from first row. And even if you do this, it's fine because if it's covered, this condition will take care of it, right? So you do DFS heights I0 Pacific. And you know what? First row, and you can also here you can do last row, which will be for which you can do something like this. If not Atlantic, and for last row it will be heights dot length minus 1 and j. So you can just do DFS heights dot length minus 1 j Atlantic, right? And similarly, first column and last column we can do. So we could do if not Atlantic, I and j will be heights 0 dot length minus 1. Then you can do DFS heights I and oops. Right, so we essentially based on that we get all the nodes that will go into Pacific and all the nodes that will go into Atlantic. And eventually we have to return a list of integers. So let's go through each and every node. I think there was one problem in the DFS, which is we are starting on the Pacific Ocean and going inland. So the height has doesn't have to be less, but height has to actually be greater, right? Next guy that we're going to use height should be greater so that it can flow into me. All right. So in this case, we go. So if basically if its water flows into both Pacific and Atlantic, then you will add it into the list. So we have a list of integers. Okay, so you define um, a list of integer result equals new list, and if that is the case, then you will add. So oops, so you will add icon j, right, and then you will return this result. Let's run. Okay, we get a legal start type of move. So let's just do simple gains. Let's just do static. Line number 55. Run. Okay, the two test cases passed. Let's submit. Index out of bounds exception. Where did we miss? XY heights. This has to be heights of 0. All right, submit again. And it gets accepted. All right.